So this is a La Nina year, and a La Nina year is they happen very randomly, and they happen less often than an El Nino year. But a La Nina year is kind of an amplified normal year. So, like we talked about in the last one, the El Nino pushes all those warm water this way, and causes upwelling over here of this cold water, and it forces warm water over to the east over here near South America. This warm water evaporates. Excuse my terrible drawings, and then it precipitates over here. In a La Nina year, like I said, it's kind of an amplified normal year, and most of the charts and graphs and everything that I saw show La Nina year as mostly the same thing in a logical standpoint as a normal year. So I'm just erasing this here, and I can show this to you. So a La Nina year is basically an amplified normal year. So it pushes all this warm water this way, and causes an upwelling of the cold water over here, and all this stuff over here precipitates, all this water, evaporates, and all this water evaporates, and it forces this over here to precipitate. A La Nina year, like I said, it forces all this cold water over here, and this gives really good fishing years for South America. But then it also, in regards to North America, it forces the north part of North America up here to have a very, very cold and dry winter, while the southern United States kind of gets a wetter but warmer winter. And yeah, so La Nina is essentially, from what I could tell from online, because the book didn't have too much on it, it's basically an amplified normal year, and it forces really unusually warm conditions over here on this side of the world, kind of near Australia and all that, kind of over near China, I guess. So yeah, so that's a La Nina year. There's not a whole lot different than normal year, but it happens way less often, and it's very random. It's unable to. It's very hard to predict, and we don't know too much about why it happens.